Hello guys, welcome to Fire Racer Workshop, and in today's video we're going to be performing an experiment on OrCAD. Now the first part of this experiment has already been performed, so click on the pop-up I button to check out the experiment first, because I've covered a lot of basics in that video, and please do check out that video, otherwise you won't be able to understand this video which I'm making right now. So in this particular experiment, the aim of the experiment is to study the rectifier circuit, and in this particular video we're going to be studying the center tapped rectifier. Now I've already covered the half wave rectifier circuit on OrCAD in my previous video, so click on the pop-up I button. So do check it out before you watch that video. Please go and watch that video. And I've just covered all the three type of rectifier in real life, in the sense I've just made the circuit and used my oscilloscope to probe different outputs and inputs. So I've just shown them on my oscilloscope. So click on the pop-up I button to check out those videos as well if you're interested in that. If you're interested in only the software, then just stick around here and watch this video till the end. Now let's just get started. Let's just fire up the OrCAD software. Click on the OrCAD. Now we'll click on OrCAD PCB Designer Professional with PSpice and click on OK. Now let's just give it some time to load up. Now guys, in this particular experiment there is no center tap transformer that's available on OrCAD, so we're gonna be making some adjustments. So you have to just watch this video really carefully, otherwise you'll just get totally confused. I'll just try to explain each and everything as they come. So let's just type in the name of the project. That's gonna be the center tapped rectifier, center underscore tapped underscore rectifier underscore trial. Let's just click on OK. Create a blank project, hit OK. Now it's better to close the start tab. That's just annoying. I don't know why do these people open up the start tab every time we just start the software. Anyways, so what you're gonna do is just tap the P key on your keyboard. Now that's gonna pop up the place window, the place part window over here. You can also go to the place and then click on parts. So this is just gonna pop up this window as well. So but it's easier to use the keyboard shortcuts. So what we're gonna do is, first of all, we're gonna import diodes. So we're gonna type in D1N4007. So we're going to be using these diodes because these are the most common type of diodes, and in my experiment that I performed in real life as well, I used these diodes only, the 1N4007. So these are also dead cheap diodes, they cost really less. So I just ordered them in bulk, and around 100 diodes cost around, I guess, $1 or $1.5. I don't remember exactly, but these are just dead cheap diodes, and these are the most versatile also. Then we are going to type in resistor R. We are going to type in, so we are going to click on R analog, double click on it, and over here we have the analog resistor. Now tap the R key on your keyboard to orient this resistor in the right way. So I'm just going to orient it in this way. Let's just place it over here, and we need to place the resistor over here as well, so that we can provide some resistance to the primary winding. And as in this video, we're gonna be using two transformers to create the center tap kind of thing. So let's just place two resistors over here. So there we go. Now let's just import the transformers. Now guys, to import the transformer, what you are gonna do is, in the libraries column right here, you're just gonna click on analog. So let's just select analog over here. You can see over here. So just click on analog and then just type in this keyword over here, XFRM underscore linear. So let's just type in XFRM underscore linear. So over here you can see the part has already arrived. So double tap on this. Now you have just got yourself a transformer. Let's just place this transformer right here, and also place the transformer, the similar transformer right here as well. You're going to place them real close to one another because this is essentially going to be connected to one another. So just place it here. Now we're all set. Now we also need a power supply, so you can just add back all the libraries that you just shot out. So tap on shift and just scroll this down to the last library and just tap on this library. Now all the libraries have been selected. Now type in VSIN. So this just gonna give you a function generator that is set to the sine voltage. So double tap on this VSIN/source. So double click on this, and now we have got ourselves a really beautiful looking function generator. Let's just get rid of that, and let's just zoom in to our project a bit so that you people can see it clearly. So let's just try to wire everything up if we have just done each and everything correctly. So let's just wire everything up. Just tap W key on your keyboard. So this is just gonna enable a crosshair from which you can do the wiring. Let's just wire this up right here. This will go right here and over here. So we are just gonna short circuit these two primary windings. So we're just gonna click on here, and over here we're just gonna short this thing to right here, and we don't need to do anything else because there's one more thing that we need to do. We need to also connect this resistor to the voltage source right here. Now we are all set. Now just add a ground. So 0 CAPSYM. This is gonna be our ground. So I'll just add my ground over here and over here as well. So wherever you add your ground, so these two nodes are gonna be interconnected due to this ground that we have just added. So let's just wire this up and wire this up as well. So what it means that this point in the circuit is connected to this point, so we just don't need to wire each and everything to there. So this is the advantage of using the software. So now let's just connect up the secondary side. So let's just connect up this thing. So let's just tap on W. It's just gonna short circuit these two windings. So this is now in this particular transformer, this is gonna become our center tap, and this is gonna become our positive winding, and this is gonna become our negative winding, like the negative wire. You saw that the center tap transformer has 3 wires that is coming out of it. So this is gonna be the first phase wire, and this is gonna be the second phase wire, and this is gonna be the ground. So this is also the center tap, so you can just like assume it to be the ground. So let's just shift the diode up a bit so that it's just like it just looks beautiful in our circuit, because we just want our circuit to look neat. We just don't need a circuit to look messy. So let's just tidy up things a bit. So let's just wire up this diode right here, wire up this diode as well, and this is gonna be our resistor. And over here we're just gonna wire this center tap to a ground. So again we are just gonna click on 0 CAPSYM. So we're gonna import this ground, and we're gonna import another ground as well for the resistor over here. So let's just connect everything, W, and right here we're also gonna connect both the diodes together, and then connect the resistor with these two, and also we're gonna connect the ground with this resistor. Now our circuit has been wired up. Now you have to make a few changes to the transformer. I've already shown the changes that you have to make in my previous video. So what you gotta do is just click on the transformer and then click on edit part. This is gonna open up a new window. Now I'm just gonna give you a brief about this thing. Go to options, click on part properties. In the coupling, double tap on that, click on name and value, hit enter. And in the inductance, double tap on that, click on name and value and press OK. In the L2, click on name and value and then press OK. That's all what you need to do. Then press OK. Now you can see we have the option of changing the primary inductance, secondary inductance, and the coupling of the transformer. Let's just cross out this window, and you're gonna tap on update all. Yes, yes. Now you can see both the transformers are now having adjustable coupling and inductance values. So let's just shift this thing also up a bit, because the circuit is otherwise gonna look a real mess. So let's just tidy up things a bit. So over here you can see this is the coupling and the inductance value for the lower transformer. This is the coupling and the inductance value for the upper transformer. Now I think we just disconnected our ground right here, so I don't know how it happened. So anyways, so let's just set the coupling to 0.99. Then we are going to use the formula of, like, for example, now we want a transformer. So for example, now first of all, let's just set the voltage. So offset voltage is going to be 0 volts. Amplitude is going to be 170 volts. So this is the peak value of the AC mains voltage that we get. So the AC mains voltage, the RMS value is around 120 volts at 60 hertz. So we're going to type in 170 volts. So just tap on OK. And the frequency, let's just select 60 hertz. So 60, that's it. Just select these all and just move it away from these things. So what we want our transformers to do is to step down the voltage. So we have to use a reduction ratio of 10 times. So we want the transformers to just step down the voltage by a factor of 10. So accordingly, we'll just select the inductance value for the L1, L2. So for the L1, I'm gonna go with 2000 microhenry. Please don't select not microhenry, it's millihenry, not microhenry. I don't know why I just like say it the other way around, micro to milli, milli to micro. Anyway, so this is 2000 millihenry. Please be careful, don't just set it to microhenry, otherwise the circuit won't just simulate properly. Now L2 value is gonna be 20 millihenry. Now similar goes for here as well. I'm just gonna change the coupling to 0.99. You can just leave it at 1 also, but it's just like makes a bit more sense to like choose a bit more realistic value of the coupling. However, this type of coupling is also like really rare, so coupling is also not that high. So let's just change the inductance value over here also to 2000 microhenry, millihenry, not microhenry. You see, I have this habit of just saying micro, milli. I don't know why I do get confused between these two. So I don't know how this equal to sign came over here. So this is L2 value is 20 millihenry. The L1 value is 2000 microhenry. So we all set. Diodes are all set. Resistor value we're not gonna change. So resistor value is gonna remain the same. We're gonna change the resistor value right here. I'm sorry, I just double clicked on the resistor. Let's just close this tab. So we have to just double click on the resistor value right here. So over here, let's just change this value to 10 ohms. Because see, these inductors are ideal. So these inductors, like, we just need some resistance in series with these inductors, otherwise the circuit ain't gonna simulate. So it just shows error. So I don't know how. So but you just gotta follow this step. So let's just go with the flow and just set the resistance value to 10. And now what we're gonna do is let's just mark some voltage points on which we can perform our measurements. Let's just type in VCC. This VCC CAP SYM. So this is what we're gonna import. So over here, I'm just gonna mark this point right here in my circuit. So this point and this point as well. By the way, we just need to mark this point. I don't think we need to mark this point right here. And right here, we're just gonna mark this point, and this point. That's all. So over here, I'm just gonna type in V in plus. So we're just gonna assume it to be the positive one. Like we're just like naming it. So it's of course not positive because it's just AC voltage. So we're just gonna name it V in minus now. And this is gonna be our V out. So now this is gonna be our input voltage. So let's just change it to V mains. So this is gonna be our mains voltage that we are getting. As you know that these 2 points are shorted in our transformer. So this point and this point are shorted together in our transformer, essentially with this power source right here. So we just like need to just mark one V mains. And now I'm just going to explain the circuit like in brief. So otherwise the faculty that's just taking your class, if my video is being referred in a class, so she's just going to explain you, she or he is going to explain you all the things. So over here, this transformer is essentially going to convert the 170 volts peak voltage to 17 volts peak voltage. So it's just going to convert the 120 volts RMS. So let's just like talk in RMS. So this is going to convert the 120 volts RMS to 12 volts RMS. Similar goes with this transformer. So this is also going to convert 120 volts RMS to 12 volts RMS. Now essentially what we are having is 12 volts RMS over here, 12 volts RMS over here. So we have just shorted these two. So over here between these 2 points we are going to have 24 volts RMS. And if we take this to be the reference, so this will, if we take this to be the reference, so these two waves are going to be 180 degree out of phase. So this is how we have generated a center tap transformer. So this technique can be used because the center tap transformer ain't available on OrCAD software. If you know it's available, and the transformer, the particular transformer, I know it's available, but it cannot be simulated with PSpice. So only this is the only way that I could find in which you can just simulate this circuit on PSpice. So let's just follow this for a while. Otherwise you can also use some op-amps in inverting configuration and non-inverting configuration as a buffer, like set to unity gain, and then just generate the 180 volts phase shifted sine wave. But this is like looking more realistic, and I just don't want to explain op-amps in my videos, otherwise the students are just going to get confused. So because all these videos are going to be watched by first year students, so I just don't want to confuse those. So let's just simulate this circuit. Let's just, I think I've just like set all the parameters right. So 10 volts, 10 ohms, 1 kilo ohm. So resistor we are just going to take 1 kilo ohm. So I think all the things are right. Let's just click on PSpice and create a new simulation profile. I'm just gonna name it trial. You can just name it anything, trial 2_2, and let's just go with trial_5 because I think I just created trial_2. So let's just create this thing. Now it's just gonna ask us to edit the simulation profile. Now as you know that we are not gonna be using either the DC sweep nor the AC sweep. We are going to be viewing our circuit in time domain analysis. So analysis type will be time domain. So it is essentially a type of oscilloscope. So you could view your circuit like with respect to the time. So we can view all the voltages that are changing in the circuit with respect to time, and it's just going to take particular number of samples. It's just going to run a circuit for like a fixed duration of time, and it's just going to take some samples and it's just going to display it on the screen. So it's essentially like an oscilloscope. So not completely as an oscilloscope because the readings are not at real time. It's just like analyze the circuit at once and then just like spit out all the values. So the runtime we are just going to set it to, like for example, now the AC frequency that we have used is 60 Hertz. So let's just calculate the time period of the wave. So that's going to be 16 milliseconds. So we're going to simulate a circuit like we want the runtime to be at least 80 milliseconds, so that we get at least 4 waves of our circuit. So we just need at least 4 complete waves to analyze the circuit properly. So, and we want the maximum step size to be 0.1 millisecond. Anyways, let's just apply these changes, hit OK, and let's just simulate this circuit. Go to PSpice and click on run. So it's just simulating the circuit. Over here we have just like reached the simulation window. Let's just add a trace and let's just remove all the unwanted components. So first of all, I'm just going to show you how the voltage is, like how the transformer is performing. So what I'm going to do is I'm just going to mark in V mains, V in plus, V in, V out, not V out. We're just going to cancel in V out, V in minus, and let's just cancel out each and everything. Let's just do it again. V mains, V in minus, and V in plus. So these are the 3 things that we are going to be simulating. You can see the trace expressions over here. So there are 3 things that we are going to add in our trace. So let's just hit OK. Now you can see a beautiful trace. Now the green one is the input sine wave, the 120 volts RMS sine wave, and the blue one is gonna be the upper terminal. For example, now this terminal is the blue one. So over here we are getting the output to be around 120 or like 12 volts RMS, and the red one is the voltage that we are getting at this particular point, the point that's below the circuit, like on the bottom side of the circuit. So that's just 180 degree out of phase. Now you have just seen like this is just like looking beautiful. Now you can also like perform some cursor measurements. So let's just add the cursor and just place it right here. So you can see the peak voltage that we are getting is around 167 volts, and the V in minus is 16.607 and the V in plus is 16.605. So anyways, so let's just delete all these traces, and now let's just add a trace. Now there's one more setting that I need to show you. You can also split your screen in this particular software, so you can also do add plot to window. So first of all, let's just add a trace for V out and V in plus and V in minus. Now the V out is the output that we are getting from the rectifier. The V in plus and V in minus are the inputs that we are giving to the circuit. Now you can see how beautiful the graph is looking. Now the green one is the output that we are getting from the rectifier circuit. Now you can see all the positive bumps. Let me just add another window, and let's just add the trace of only the V out. Now you can see how beautiful the V out is looking like. Now let's just go to this window and delete all traces, and let's just add the trace of only the inputs. So that is going to be the V in plus and V in minus. Now you can see these are the V in plus and the red one is the V in minus, and you can see the V out is just continuous bumps of voltage that we are getting. Let's just add some capacitance to the circuit. Let's just sprinkle some capacitors to the circuit. We're just gonna move the diodes a bit. Let's just cross this out first of all. Now we're gonna move the diodes a bit backward, so we create space for adding some capacitance. Let's just type in C, and we have got the value as C analog. Double click on this, tap the R key on your keyboard to rotate this thing. Just click it, like just connect. Wait for a second, let me just connect it somewhere else. Now again we're gonna tap on C. Let's just click on R, rotate this thing, and we're just gonna connect it over here. Now let's just add a ground, 0 CAPSYM. So essentially we don't need to connect the capacitor to both the sides. We just like connect one side to the V out and one side to the ground. It's essentially gonna add capacitance to the circuit. So let's just wire this ground up. Now the ground is perhaps been wired up, so we're gonna change the capacitance value. Let's just move this further back, so a circuit again looks neat. Neatness is the key to success. So anyways, so let's just mark this capacitor as 220 microfarad, and just hit OK. So this capacitor value has been changed to 220 microfarad. Now let's just simulate the circuit again. Hit on run. Now in the plot, now I'm just gonna add another window. Now let's just click on trace. Now for example, this window has been selected. Now click on trace, add trace, and we're just gonna add in our output voltage over here. Now in the trace on the bottom side, now we're gonna add the trace for the V in plus and V in minus. So you can see there's a bit of distortion in the sine wave as the capacitor draws initially a large amount of current, so this sine wave is getting a bit distorted. So otherwise you can see the continuous positive bumps that are occurring. Let's just add the trace for one of the sine waves on this one as well. So let's just add in the trace for V in plus. So you can see over here, you can see the continuous bumps that we are getting. The capacitor is just getting charged again and again, and in this condition the bumps are like occurring less frequently, and the ripple voltage is much less than what we got for the single the half wave rectifier, because it's just like capacitor, the capacitor is getting charged twice per cycle. So this is the reason why it's just like why the bumps are like smaller in this particular circuit. This is similar results that we got on our oscilloscope as well when we simulated in real life. Not simulated it, actually we performed the experiment. That's not called a simulation, that's called performing the experiment. So that's all guys. So we have just successfully simulated this circuit. Thank you all for watching, and be sure to leave a like, comment, and just share this video with your friends. Whom do you think like need this video, because this video is going to be really helpful for the students who are like preparing for their practicals. So I hope you like it. So thank you all for watching. See you in the next video. Bye bye.